So the real world is hard. I actually, for my PhD, I did work with physical robots, um, and they always break, and they're hard to control, and the real world is messy, and nothing ever goes the way it's supposed to. I mean, it's interesting, it's a fun challenge, but the real world is a hard place to work. And so, if you've got a manufacturing floor, for example, where you've got physical devices that are doing things, and you're thinking, hey, I'd like to make a change of some kind, wouldn't it be way better if you could sort of experiment with that change in software, which is going to be fast, you can cycle on it really quickly. If your change was ill-advised and it would break the entire flow of things, it's okay because you broke it in software. You didn't sort of bring the plant crashing down. And so a digital twin is nothing more than a sort of a software artifact that behaves a lot like the physical hardware artifact does, and it's informed by data, right? So the idea is that you're gathering all this data. We saw there's 1,000 petabytes of data every year coming from the manufacturing industry. Then what I can do, I can put sensors on there, and then I can gather data. I can use that data to construct this digital twin, right? I want this thing that behaves like the actual physical system does in the same situations. But then I can do things like data analytics, I can build simulations, I can monitor performance. And then, based on what I learned in software, I can go back and do optimizations in hardware. And the idea is that you hope that there's enough fidelity between the digital twin and the sort of physical side of things that the changes in the experimentation that you're looking at on the software side are going to be close enough that they will have similar effects on the hardware side. So I actually have interacted with some people at GE Research. It's now GE Vernova, which is their aerospace side, and they build digital twins for their airplane engines because those things are incredibly expensive. And when they build a new one, when they construct a new engine, they design it and they build it, they really need to be able to test it in software. They can't afford to have these things go out into the field and have any flaws or defects or failures. And so they're very careful about constructing digital twins and doing a lot of experimentation on them prior to sending the physical artifacts out there into the field. And so there are lots of situations where, a failure is so expensive in terms of money and potential loss of human life, you have to do it. Or if you build a digital twin for a manufacturing plant, it allows you a lot of freedom to sort of experiment with different configurations.